Hey, this is Mr. Aiden. We're Chemistry Honors, and we are continuing in chemical equilibrium, and we're going to go through LeChatelier's principle, the little French principle, otherwise known as the equilibrium law, but more classically known as LeChatelier's principle. So let's take a look. So LeChatelier's principle is all about compensation. You know, those guys with the big trucks at Sonic from Forest High School. Yeah, they're compensating for something. Anyway, when changes are made to a system that is at equilibrium, the system will compensate, will shift to reduce that change. It's very similar to a model would be you standing, someone pushes you on your right side, you will shift back to the right side to compensate for that change, to shift, to reduce that change. And there's three things that happen to a reaction that causes it to shift to reduce that change. Number one, concentration changes. So if we change concentration, it will shift to reduce that change. Number two, temperature. And number three, a pressure volume change. Catalysts, no change. No change at all. Adding solids, no change at all. So only changing concentration, temperature, and pressure and volume. Putting neon gas and inert gas, argon gas, nothing happens. Catalyst, nothing happens. Changing concentration, temperature, and pressure and volume, we got shifts to reduce that change, and that's called LeChatelier's principle. Let me walk you through each one of these three. Here's one where it says adding or removing concentration, LeChatelier's principle. So let's say we have this reaction right here. Nitrogen gas and hydrogen gas gives 2 moles of ammonia. So if I add nitrogen gas, it is going to shift the reaction away from that change to compensate for that change. And so we're going to make more NH3. It's going to make less H2 because it'll use that H2 to compensate for that change. So if you add, it will shift it away from that change. Let's say we add hydrogen gas. What's going to happen to my reaction if I add hydrogen gas? It's going to shift it to the right, which means we're going to make more NH3. We're going to make less nitrogen gas because it's going to use that nitrogen gas more and more and more to make more ammonia. So it always shifts away from wherever you're adding. Let's say we add ammonia. Where's my reaction going to shift if I add ammonia? It's going to shift to the reactants, which means I'm going to make more N2 and more H2 because it shifts it away from that change. So wherever you're adding, it's going to shift it away from that change. Let's take a look here. Let's say we add something like calcium nitrate, which means I'm adding calcium ions. If I'm adding calcium ions, it's going to shift it away from that change, which means it's going to make a solid. It's going to precipitate, PPT, precipitate. It's going to make a solid if I add calcium nitrate. Let's say I add sodium hydroxide, which we all know means I'm just adding hydroxide. If I add hydroxide, where's it going to shift? It's going to shift it away from that change, which means I'm going to make a precipitate. I'm going to make more calcium hydroxide solid. Now, if I add sodium hydroxide and it shifts it and makes it precipitate a solid, that means if I'm adding a base, it shifts it to the left, which means if I add a strong acid like HCl, it's going to shift it to the right, which means it will actually dissolve it. It will make more calcium ions and more hydroxide ions, which means that it will dissolve. And that's how a sinkhole happens. A sinkhole happens when we have acid rain in something like calcium carbonate, limestone, calcium hydroxide, and it will shift it this way to compensate for that change. So if you're adding any kind of concentration, it shifts it away from that change. If you're adding something that will remove concentration, it shifts it towards that change. Okay. The second one, here's an example. Let's say I add iron nitrate. Okay, which means I'm adding iron ions. Where's it going to shift if I add this iron ions? It's going to shift it away from that change, which means my solution will turn red. Okay? Let's say I add potassium KSCN. Okay? Where's it going to go if I add some of this SCM minus ion? It's going to go away from that change. It will become red in color. And let's say I add some FeSCN plus 2 ions. Where's that going to shift if I'm adding this? It's going to shift it this way, which means it's going to become kind of a yellowish in color because I'm adding that product right there. And so that is LeChatelier's principle when we talk about adding or removing concentration. Let's go to number 2, which is changing temperature. Now this depends if we are endothermic or exothermic. You can see right here, this is a positive delta H, which means we know that this is endothermic. Endothermic means my delta H is like it's a reactant, which means if I add heat to this, if I add temperature to this, it's going to shift it away from that change, and it will make it go towards the NO. It will make it go towards the NO. And so what happens here is if we have a reaction that's endothermic and we add heat, it's always going to shift it to the right towards the products. Okay? Which means if I have a reaction right here, which is exothermic, remember exothermic means it's kind of like I'm releasing heat. If I'm adding my heat, if I'm adding temperature, if I'm adding heat, it's going to shift it away from that change, and it's going to start producing more hydrogen gas and oxygen gas. And so LeChatelier's principle, that is changing temperature. So if it's endothermic and I add heat, it'll go towards the products. If it's exothermic and I add heat, it's going to shift to the left towards the reactants. Okay? And we go to the last one, which is changing pressure or volume. Okay, so the key with changing pressure or volume is if I add pressure or reduce volume. Remember, that's the same thing. Reduce volume of a gas. Okay, that's Boyle's law right there. If I add pressure or reduce the volume of the gas, it's always going to shift to the least number of moles of gas. Least number of moles of gas. And so you can see here, if I add pressure or reduce volume, same thing, of a gas, it's going to shift to the least number of moles. Where's the least number of moles of gas? Well, look at my reactants. I have 1 mole of nitrogen gas, 3 moles of hydrogen gas. That's 4 moles total. My products have 2 moles of ammonia, 2 moles total. Where is it going to shift in order, if I add pressure or reduce the volume, it's going to shift it to the right, to the least number of moles. The least number of moles of gas. And so that is, if I could spell gas correctly, G-A-S is how you spell gas. Okay? And so that is LeChatelier's principle. LeChatelier's principle, or the equilibrium law. If we add concentration, it shifts it away from that increase. If we increase temperature, it shifts it away from that increase. Endothermic reaction, it shifts it to the products. If we increase the pressure, decrease the volume, it shifts it to the least number of moles. Okay, let me show you a quick simulation right here. You can see here that we have COCl4 -2, and that's blue, plus 6 waters. Gives you COH2O6 plus 2, that's a red, plus 4 chlorides, plus heat. So if I add water, if I'm adding a reactant, where's it going to shift? Away from that change, it's going to shift it to the products. It should become red. So if I click on this, what do you know? It goes from this color to red when I add some water. If I add some KCl, well, what is KCl? That's Cl minus, isn't it? So if I'm adding Cl minus, I'm adding this product. It's going to shift it away from this change. It's going to turn it more blue. So you can see how this went from this color to blue when I added the Cl minus. Now if I add Ag plus, Ag silver nitrate, Ag plus, that actually precipitates with the Cl minus. It removes Cl minus. So remember, if I added Cl minus, it shifted it blue. If I remove Cl minus, it should shift it red. And so what do you know? It shifts it red when I make it precipitate. And this is, you can see heat is a product, which means it's exothermic. Exothermic, which means if I add heat, it shifts exothermic reactions to the reactants. It should turn it blue when I add heat. And what do you know? It does. And so that is an example of LeChatelier's principle. Hope this helped. Make sure you do your self-assessment. I'll catch you all on the flippity flop. See you guys. Bye.